So solving percent problems. So we talk about percent increases or decreases when we talk about shopping discounts, wage increases, the inflation rate, interest rates, population growth, energy consumption. There's many other applications of using percents in the real world. So we're going to do a few examples, and like I said, the first couple we will not use the calculator because we don't need to, but the third one we will need to use the calculator. So here we go. Determine the value of a number if 40% of a number is 72. So we've got what we need here. So what we know, if this is like if this is 0 to 100%, we're going to say about 40% of it. 40% of it is 72. And yes, if we do another 40%,
37.
that's 72. And then what Brooklyn and Bentley both said is, then we have 20% because 40 plus 40 plus 20 makes 100%. And
72.
but the relationship here is 20 is half of 40. 20 is half of 40. And what's half of 72? Well, it's 36. So then what we need to do is we need to add 72, 72, and 36 together. And when we do that, we get 72 plus 72 plus 36 is 180. So the answer is 180, okay? So 180 is the full number, all right? That's actually some really, really, really good thinking by Bentley and Brooklyn. Now, what I would have done to do this question, and the approach I'm going to show you is probably going to work for a lot of the practice questions you get. Mind you, Brooklyn and Bentley's will too, is by using a number line. So if I use a number line here, I'm going to go, I guess probably the easiest way of doing this would be 1, 2, 3, 4, 1, 2, 3, 4. We know that 40% is 72. So I would have just put like a little mark at 40 for 40%. And I would have said, okay, we've got 72 here. I would see that we have 1, 2, 3, 4 chunks make 72. And this one would be 10%, okay? So if I'm going to divide 72 into 4 pieces, so 72 divided by 4 is what? It's 18. So that means that 10%, oopsies, 10% is 18. And that means that every one of these is 18. So it'd be 18, 36, 54, 72, 90, 108, 126, 144, 162, and 180. So I would have got the same answer, but using a number line. But like I said, the way Bentley and Brooklyn broke that down was very clever and very creative, and I really like it, okay? The whole idea is we have to make 100% knowing what 40% is, okay? 3 years ago, the price of an 18 pack of eggs was $4.10. The price increased by 40%. What is the new price, okay? So what we have to do is take $4.10 and we have to add 40% to it. We would move the decimal place over, but we move it this way, so it'd make 41 cents. So we're going to move the decimal place one spot to the left, which means that 10% is 41 cents. Okay? So how many 10% go into 40%? 4. So we need 4 times 41 cents. So what would be 4 times 41 cents? Be $1.64. So $1.64 represents how much the price of eggs went up by, okay? That represents how much the eggs went up by. So the new price, how do we find the new price? Right. So $4.10 plus $1.64 is $5.74. So as we can see, the first two examples, we did not need our calculator, okay? We just needed a number line or some other similar kind of line of thinking, and or just using the idea of 10%, we can just move the decimal over. Good enough. Now the next example though, we will need a number, rather a calculator, okay? So let's go and do so Mr. Hutton's old air conditioner used 4,000 kilowatt hours in energy every year. When he replaced it, the new unit uses 1,400 kilowatt hours in energy. What was the percent decrease in energy used? Okay? So to answer a question like this, to find the percent change, whether it's an increase or a decrease, the formula is new minus old divided by old times 100. And we'll use our calculator to help us out. So really it's just the new number minus the old number divided by the old number. After we do that subtraction, order is important, and then we'll multiply by 100. So that's going to be 1,400 minus what? 4,000 divided by what? 4,000 times 100. So 14 minus 40 is minus 2,600. Because it's negative, that's telling us it's a decrease, it's going down, and that's fine. And we're going to divide by 4,000, and we're going to multiply by 100. So what is negative 2,600 divided by 4,000 times 100? We get negative 65%. Again, the only thing the negative tells us is it's a decrease, which we were asked in the question about anyway. We're told that it's decreasing, and we can even tell because the numbers are going down, it's a decrease. The negative tells us it's a decrease, but it decreases by 65%. Now, this is a word problem. Word problems deserve a sentence. So we'll say the percent decrease is
times it by 100.
So the energy decreases by 65%. We don't have to put the negative in there. If we say it decreases, we're saying it's going down.